Hello everyone and welcome to e-learning day. How exciting to get to hear some notes during your e-learning day. Anyway, today we are going to graph linear inequalities in two variables and find the solutions. So first of all, linear inequality in two variables where x and y can be written as, just like linear equations is a straight line. The formula or equation for linear equations is in slope-intercept form, y equals mx plus b. So we're going off of that, y equals mx plus b, and we're writing linear inequalities in the same form, just written with an inequality symbol. So hopefully you guys are taking these notes with me right now. I gave you the note worksheet and also the homework assignment on Friday before you left. If you did not get that for some reason, you can click on the links on the Canvas page and download the notes, and you can follow along that way or print them at home or just write them out on paper. All right, here we go. So a linear inequality in two variables, x and y, can be written as y is greater than mx plus b, y is less than mx plus b, y is greater than or equal to mx plus b, and y is less than or equal to mx plus b. So all of those are still in the form y equals mx plus b, except using the inequality. All right, to find a solution of a linear inequality in two variables, that means it's an ordered pair like x comma y that makes the inequality true. Okay. Remembering our inequality symbols. The first inequality symbol is less than. Remember, it looks like that L, if we open it up a little bit more. This one is greater than. This one is less than or equal to. And the last one is greater than or equal to. Okay, first example, tell whether the ordered pair is a solution of the inequality. So remember, to tell if it's a solution, we take the ordered pair x comma y and we plug it into the inequality to see if it's true. So let's plug it in. We have 2. X is negative 1, so I'm going to plug that in for x. Plus 9 is less than negative 3. I need to figure out what this side equals. So 2 times negative 1 is negative 2 plus 9. Negative 2 plus 9 is 7. 7 less than negative 3. Is that true? Is 7 less than negative 3? The answer is no. Therefore, negative 1 comma 9 is not a solution. Yes, you need to write all of that in order to get the points. All right, take a minute to try number 2. You can pause the video and try it out for yourself. As you do that, I'm going to be writing it out and giving you the answer as well. All right, as you did it, you should have gotten 8 is greater than or equal to 8. Is that true? Yes, that is true. So 2, negative 2 is a solution. But what if it said only 8 is greater than 8? Would that be true? The answer is no, because 8 is not greater than 8. We know that. 8 equals 8. So the only reason it's true up here is because it has the line underneath it to make it equal. So this one would be no. All right. Graphing linear equalities in two variables. The graph shows all of the solutions of an inequality in the coordinate plane. That means that everything that is graphed will show all of the solutions of the inequality. So remember, when we just drew a straight line, if we graph just a straight line, so if we have a graph and the equation is y equals x plus 2. So we know we graph it at 2, and we are going to go up 1 over 1, so we're going to have a nice line that looks something like this. And I know it's not accurate according to the graph because I don't have graph paper. But just imagine that we had a line that said x plus y equals x plus 2. The solutions to the line, okay, the solutions to this equation right here is everything on the line. So every point on the line is a solution. Okay, so when we're talking about inequalities, the solutions are going to be a little bit different. Okay, and I'm going to talk about those in just a minute. So first of all, we have to graph the boundary line. Okay, so that is just like the equation. We're going to graph the line just like we would a regular equation, but this time it's called a boundary line because it's going to represent different things. So graph the boundary line for the inequality. You need the slope and y-intercept. All right, we're going to have a dashed line for the inequalities that do not include the equal sign. So it's just going to be greater than or less than. So a dashed line is going to be the greater than or less than symbols. That's going to create a dashed line for us. Okay, because that means that the solutions are not on the line. The dashed line means that the solution is not included on that line. However, a solid line is going to be for greater than or equal to or less than or equal to, which means there is a solid line underneath the inequality, which is going to create a solid line when we graph. And the solid line means that the solutions are on the line also. All right. Then we're going to look at the shading. We're going to shade above or below the line. To shade above the line, that means all of the inequality symbols that are representing greater than. So greater than or equal to is going to tell me I need to shade above the line because it's all the numbers that are bigger. Below, we're going to use less than or equal to. That means it's all solutions below the line. And then we can also check a point in the shaded region. So once we shade it, we can check a point in the shaded region, see if it is true. If it's true, then we know that we graphed it and shaded it correctly. All right, so that's all of the basic stuff that you should have learned last year that we're going to need to graph these inequalities. Okay, looking at example 2. Before we get into that, we're going to graph the inequalities below. And remember to flip the inequality if you multiply or divide by a negative. So if we have to solve the equation and put it into y equals mx plus b, remember anytime that you have to divide by a negative number or multiply, you must flip the inequality. All right, looking at the first one, number 1. Y is less than or equal to 2. we're still going to think about it as if it was y equals 2. What's that going to look like on the graph? Well, remember, it's going to be a dot on 2 on the y-axis. It's a horizontal line. Okay, so we know y equals 2 is horizontal. Okay, and so we know we're going to have a horizontal line, but before we draw that line, we have to look at the inequality symbol to see what line we're going to draw. So because it's less than or equal to, it has the equal to sign underneath it, I know it's going to be a solid line, so I'm going to write that down. And it's less than, so it's going to be shaded below. So now let's draw the line. I need a solid line, and I need to shade below, which means underneath the line. So below means underneath the line. And you could just shade lightly. You don't need to make it real dark, just because when we get ready to do systems of inequalities, we're going to have to practice shading lightly. All right, we're going to go down to number 2. This one is not in slope-intercept form. So in order to graph it, we must put it into slope-intercept form first. So that means I'm going to subtract x from both sides. I get y is less than or equal to negative x minus 4. And now I can write the information that I need to graph. So m equals negative 1 over 1 is my slope. B is negative 4. I'm going to look at my inequality symbol, which is less than or equal to. So I know I'm going to have a solid line, and it's going to be shaded below because it's less than. All right, now I need these 4 things. I want you guys to always write those down for every equation or inequality that we do. So you'll need to write all 4 of those things down when you do your assignment. Okay, now let's graph. We're going to go down to negative 4 on the y-axis. Our slope is down 1 over 1. It's a negative slope. I need to put all of my dots, as many as I can, on the graph. It's a solid line, so I can draw my solid line through the points. And I need to shade below. How can I tell where below is? It's underneath the line. Okay, so if you put your little guy walking on the line, right? He walks on top of the line. But if I try to put a guy below the line's on his head. Okay, so wherever you draw it, if the line is up above his head, that means that that's below the line. So we're going to shade below, which means underneath the line. Now you can't really go by left or right because it depends on the slope of the line. If the slope is positive, it's going to be on the other side of the line. Okay, so you just have to look to see what the line looks like and where below is. All right, we're going to go down to number 5. X is greater than 3. This one's a little bit tricky because number 1, it's tricky to begin with because it's a different type of equation. It starts with x equals. And remember, anything that starts with x equals is going to give us a vertical line. So let's start with the vertical line. We know we're going to have a point on the x-axis because it says x equals 3. Okay, it's going to be a vertical line, but I need to look at my inequality. If it's dotted or solid, this one is going to be a dotted or a dashed line because there's no equal sign underneath. And it's going to be above. We're going to shade above because it's greater than. All right, so let's make our dotted line vertically through 3 on the x-axis. Notice that it's clearly a dotted or a dashed line. I must be able to see that in order to give you credit. If I can't tell if it's dotted or solid, then I won't give you credit for it. All right, we're going to shade above. This is another reason why this one is tricky. because it's not a slanted line, it's not a horizontal line, so above is hard to tell where that is. So we have to actually read the graph. It says all numbers greater than 3. So all numbers greater than 3 are to the right of 3. So I would shade to the right on this one. Okay? So if I were to pick a solution, my solutions would be anywhere in the shaded region. So I could have lots of solutions. However, on the line is not a solution because it's a dotted line. So I cannot say that 2, 2 is a solution because it's not. It is on the dotted line, and dotted lines don't include the solutions. But anywhere in this shaded region is a solution. So if I pick any point in the shaded region, it's greater than 3. Okay? And if you think about that, that makes sense because if I pick a number on the dotted line, if x is 3, 3 can't be greater than 3. 3 is equal to 3, so that doesn't work. But 4 is greater than 3, 5 is greater than 3, 6 is greater than 3, 7 is greater than 3, and so on. All right, let's go back to the top and look at number 3. It's not in slope-intercept form, so we need to put it there. So that means I have to add x to both sides. I get 2y is greater than x plus 2. I have to divide everything by 2. So y is greater than 1/2 x plus 1. All right, I know what my m is. That's a half. My b is 1. I'm going to look at my inequality sign. It's greater than, or here, y is greater than. So just because it's greater, that means it's going to be a dotted line. And it's going to be shaded above because it is greater. All right, let's graph it. B is equal to 1, so I'm going to have a 1 here. My slope is 1/2, so I'm going to go up 1 and always to the right 2, up 1 to the right, up 1 to the right. And I'm going to fill up my graph as much as I can. All right, I cannot leave my graph like this. Even though it's a dotted line, I have to clearly show the dashes that are going between those dotted lines. Otherwise, I'm going to assume if you leave it like it is right now, I'm going to assume that you didn't know what you had to graph and that you just left the graph blank. Okay, so we clearly need to make the dashed lines in between those dots just so that I can tell that it's a dashed or dotted line. Make sure you put your arrows on the ends. And then we're going to shade above. So everything above is up here above the line. All right, number 4. We still needed to put it into slope-intercept form, so this one we have to be careful with. All right, we're going to subtract the x from both sides. Negative 2y is less than negative x. We really don't need the plus 0, but some people like to keep the plus 0 there just for the y-intercept. I'm dividing by a negative 2. Okay, when I divide by a negative, remember, we have to do what? Flip the inequality sign because we're dividing by that negative. Okay, so we flip the sign. We have y is now greater than 1/2 x plus 0. Because the negative divided by negative is positive, so that's 1/2 x, and 0 divided by anything is still 0. So my m is 1/2. My b is 0. It is a dotted line because of my inequality, and it is shaded above. So we're going to start at 0 on the y-axis. We're going to count our slope up 1 to the right 2, always to the right until we do the other side of it, and then we have to go opposite slope. It's a dotted line, so I'm going to show my dashes in between each of those dots. Draw my arrows, and it's shaded above. All right. The last one that we're going to do on this page before we get to the word problems is this one. Okay, we have 2x minus 3y is greater than or equal to 6. I need to subtract 2x from both sides to get into slope-intercept form. I have negative 3y is greater than or equal to negative 2x plus 6. Divide everything by negative 3. When I divide by a negative, I have to flip my inequality. So y is less than or equal to 2/3 x minus 2. My m is 2/3. My b is negative 2. It's going to be a solid line and shaded below because it's less than. Negative 2 on the graph. Up 2 over 3 to the right. Up 2 and 3 to the right. Keep doing it till we fill up our graph. It's a solid line, so I'm going to go ahead and draw the solid line straight through there. And it's shaded below, so it's everything underneath the line. Okay. All right, so there we have it, a review of graphing inequalities in linear inequalities in two variables. All right, we're going to skip example 3 for right now. We're going to go to example 2 on the back. All right, student government is selling class t-shirts and glow sticks at the homecoming game. T-shirts are $20 each and glow sticks are $2 each. In order to cover the cost of supplies, they need to make at least $900. Use X as the number of t-shirts sold and Y as the number of glow sticks sold. So we're going to write and graph an inequality to show how many t-shirts and glow sticks must be sold in order to break even. All right, first we're going to write the inequality. So we need t-shirts are 20, and we're going to use X to represent the number of t-shirts, so 20X plus glow sticks, which is $2 each, so 2Y, has to be at least, which is greater than or equal to 900. All right, we could solve this one of two ways. We could solve it and put it into slope-intercept form. But if we put it into slope-intercept form, I'm just going to give you the equation. If I put it into slope-intercept form, it's going to look like this. Y is greater than or equal to negative 10x plus 450. All right, well, if I look over here at my graph, okay, these are going up by 50, okay? I know that my y-intercept is at 450, but if I try to count my slope, I can't go down 10 and over 1. They go down by 50s and over by 5. So that creates a problem, okay? We could convert it, right, and make it, if we multiply the 10 over 1, both by 5, it would be negative 50 over 5, and we could graph it that way, which would work, okay? But what I really would like you to do is not put it into slope-intercept form. I want you to use the x and y intercepts. So we're going to use the cover-up method to solve for that. Remember, we have to find the x-intercept and the y-intercept. The x-intercept, we cover up y, solve for x. So 20x is equal to 900. Divide by 20. So x is equal to 45. The y-intercept is 2y is equal to 900. So y is equal to 450. I'm not concerned about the inequality signs right now because all I'm trying to do is find the x and y intercepts. So it doesn't really matter what the inequality symbol is at this time. All right, so we already graphed the y-intercept up here at 450. We're going to graph the x-intercept here at 45. And now all we need to do is draw the line from point to point. So the only thing I would highly recommend is that you have your ruler or straight edge because that's going to help us more when we get ready to answer some questions. Okay, so we want to make sure that we have some nice lines. Okay, and mine is hard to draw because I can't get them straight on this. But if you have a ruler, that would be helpful. All right, so now that we have it graphed, we know it's a solid line because it says at least it's greater than or equal to. So now I have to graph the greater than. So we're going to shade above. It's a solid line, shaded above. So there's my graph. The point here, the line, okay, this line right here is where they break even. Every point on the line is where it breaks even. That's where they make their money or break even on what they sold, okay? Every point up here is where they're making a profit. They're actually making more money, okay? So all of that is where it's greater than or equal to $900. That's where they make more than $900, okay? And on the line is where they break even. They make $900. All right, so if 30 t-shirts were sold, what is the minimum number of glow sticks that must be sold to break even? So if we look here on the graph at 30 and we go up, okay, we can see from the graph that we need at least 150 glow sticks. However, it's not always clear to see. What if I didn't draw my line straight the way I needed to? Okay, so what I need to actually do is take 30 t-shirts and we're going to plug it into our equation. So since X is representing the t-shirts, I'm going to take 20, plug in 30, plus 2y is greater than or equal to 900. Okay, so now we just have to solve for that. When we solve, we should have gotten y is greater than or equal to 150. Okay, that checks it. This one verifies that it is 150 glow sticks. Okay, so we can check our work by plugging it in. We can verify using the graph. All right, the second part, would the student government be able to cover the cost of supplies if they sold 22 t-shirts and 250 glow sticks? So would they be able to cover the cost? That means they need more than $900 for that to cover the cost. Okay, so let's see if that works. We have 20 times the number of t-shirts, which is 22, plus 2 times the number of glow sticks, which is 250, must be greater than or equal to 900. If we add all of that together, we're going to get 940 is greater than or equal to 900, and yes, they can cover the cost. Okay, let's take a look at our graph and see if it lines up with it. 22 t-shirts is about right here. And then I need to follow that up to about 250. So if I follow that up to about 250, it is above my line, okay? So therefore, it's in the shaded region, which tells me that it's going to be more than the break-even cost of 900. So that does verify that my answer is correct. All right. We're going to stop there, okay? There is another word problem example, but it's pretty much the same type of word problem. So you can get the gist from number 1. Okay, I think that is it. So hopefully you have a great e-learning day, and I will see you all on Thursday.